Hey folks, well thank you for joining us everyone today on track 2 on this beautiful June day from whichever time zone you might be in. Today Poppy and I are going to be presenting our talk Overheard in Infrastructure.
So hi, I'm Poppy. I'm a business analyst based in the Manchester office of Thoughtworks. And for visually impaired people, the description of me is that I've got kind of dark coloured hair, a black t-shirt on, and very pink eyeshadow today. And to be honest, I don't really know that much about infrastructure. But the reason I'm going to talk to you today about infrastructure is because I've been fortunate enough to work on a couple of teams where we've been building infrastructure platform products. So I'm going to talk to you about that today.
So I'm Chris Shepherd, or Sheps. I'm a tech lead from the Manchester office of Thoughtworks. And I guess for those who are visually impaired, I'm sort of mid-30s. I'm wearing glasses, increasingly blonde hair, thanks to the unnaturally sunny weather here in Bolton at the minute. I've done a bunch of infrastructure over the last sort of few years or so. And I'm gradually sort of realizing that infrastructure is this sort of ubiquitous and inescapable thing. And so it's a really good idea to try and learn how to do it right.
So what is infrastructure? So in basic terms, I've learned that it's all the stuff that developers need to build great products. So it's the building blocks that a customer might not necessarily see, but it can impact them. So anything from the code repository to monitoring services, or even things like secrets management.
And so teams have this same need, but they tend to be building the same stuff again and again. So using these infrastructural components, teams might build these little building blocks to build larger things to solve common problems, things like alerting and feature flags and those kinds of things. But yeah, again, what you tend to see is that the same stuff tends to be built 500 times in 500 very different ways. And it's all wasted effort though, right? There's got to be a better way of achieving these common goals. And this is kind of where platform comes in. It's a slightly different abstraction for talking about things hosted in the cloud for achieving common purposes.
And these platform products, these infrastructure products might look quite different and they might have different users, but actually they are the same in terms of the principles that you need to kind of follow to make successful products. In terms of the kind of product thinking, agile ways of working, it's not actually that different. And to make it a success, you do need to remember to follow this. And for some reason, when we've worked on teams, people seem to forget this. So that's why we want to talk to you about it today.
So this talk is about some of the common pitfalls and some of the mistakes that folks might run into when building out these platformy type things. It's not a silver bullet, but we're going to suggest during this talk 7 principles that we think will make things a little bit easier and that road a little smoother. You'll see there's a natural order to some of these principles that we'll be talking about, but don't feel like there's some magical sequential recipe that you have to follow. Like, feel free to pick and choose what might work best for you. Again, this isn't a chronological list. So please sit back and finish your complimentary gin and tonic and put your trays in the upright position, your seats back. We're going to take you for a whistle-stop tour through infrastructure.
Awesome, thanks, Chris. So one of the things we've heard when working on infrastructure product is this quote. So Datadog is really cool. This should be our next platform product. But what's actually wrong with this statement? No one actually asked the users if this was needed. So for context, Datadog is a performance monitoring tool. So no one asked people if Datadog was the thing that would, give them the benefit for performance monitoring. But also no one even asked the users, the development teams, if they actually needed performance monitoring right now. Some teams are probably just already trying to get any code into production or trying to get their APIs to play nicely with the auth systems. The last thing on their mind might be performance monitoring. So what do we need to do? Do a discovery. So one of our first principles, and something that we've seen time and time again people skipping, is the discovery stage when building infrastructure products. So what does this entail? Actually talking to development teams. And I say development teams, not just developers. So you should be talking to QAs, BAs, architects, delivery managers, all these people who are involved in the process of building normal products, because they might see different parts of that process. So maybe it's that the technical aspect of it, the infrastructure, isn't maybe that tricky, but the governance side is absolutely slowing teams down, and they're not able to get approvals. So maybe you can do something about that. But, maybe it is just the technical side. But talking to a different range of people, whether you're doing interviews or surveys or, grabbing a cup of coffee with them, that's the really important part here. And just find out what's holding teams back from delivering these awesome products, what's causing them pain, what's slowing them down, but also what's going well for them, maybe what you don't need to focus on right now. And a really simple way to do this is to do event storming, which is a process made by Alberto Brandolini. And you can find out a lot more on eventstorming.com, but I'm going to just give you a little whistle stop of how I've done it before and how I think it's successful. So you basically get a wall, so a physical wall, or use Mural or whatever it is in the remote world, and basically map out all the things that happen from the start of a project to being live with production with real users. And get the team to map all that out. So again, make sure you involve the whole team here and just map out all the different things that happen between these two steps. And the really important part then is to actually put your pain points on there. So, things that are taking ages, things that break, things that are just really tricky and maybe don't have the skill set to do. Map all of those on there. And this kind of creates a heat map of themes and problem areas that you might want to investigate. And basically repeat this across different teams to see, where the common patterns are, where people are doing fine, and just see, just investigate that a bit further. And one thing you'll actually realize from talking to users, which might have been an assumption early on, is that yes, your users are developers, but actually not all of your users are the same. You might hear from some people, why should I be using this instead of building my own? I'm a perfectly capable infrastructure developer. I've got lots of experience with infrastructure as code. I've built things from scratch myself all the time. Why should I come and use a product that you've built for us? And with these kinds of people, you're going to have to be really clear on the value that you're adding and the value that you're delivering. And that's going to be really tricky with this kind of organization. And similarly, you might have some teams who actually don't have that infrastructure experience. So if you find you've got these kind of developers in your organization, you're going to be wanting to take a slightly different approach where you're really thinking carefully and hard. How do I make using my products that I'm going to build super easy and be explaining those processes and explaining terms and not assuming that everyone's got the same knowledge as yourself when you're building that. And something we do all the time for regular products that customers might be using is personas. So don't skip this step. Just because most of the developers are your users doesn't mean they're all the same. So just create a few personas based on actual people that you're meeting and actual people that you're talking to, and it just helps you keep in mind what that product should look like. And remember as well, you might not be able to build something for everyone, and that's fine too. So it might be that actually your organization's happy to let the really experienced teams kind of go ahead and build their own thing. Maybe they've already built it, so you don't actually want them to take the steps to undo that just to use your product. That doesn't make sense. So, and maybe you want to just focus on some critical products in your team and building infrastructure for them. And you're not so bothered about maybe the kind of lower priority products within your organization. So just have a think within yourselves and within your team, who in your organization are you trying to serve? Who would really benefit from these shared infrastructure products? Then prioritize something valuable. So obviously this is a really critical step. And one of the ways I like to do this is using the weighted shortest job first prioritization method. So this method's actually from the Scaled Agile framework. And you basically take the cost of delay, which is, what would it mean to me? What would it mean to our organization if we don't build this? And then over job size. So, ideally you don't want to be prioritized in something that's going to take forever to build, when you might have something of fairly equal value to your organization that's a lot quicker to build. So it just helps you get that quick view of that. And when I say cost of delay, I think it's super important to define this for yourselves. So traditionally, the weighted shortest job first prioritization technique is quite rigid, and I don't like that about it. I actually think that you as a team and your stakeholders should be defining what this is and what this means for you. So you might want to be rating things on security. Maybe this is somewhere that's lacking in your organization right now. So actually you want to prioritize things that will help improve that across your organization. Maybe you want to reduce the cost of delivery. Maybe it's taking your teams far too long to build different products, and you actually want to reduce that time and effort it takes for developers to be building these products, and therefore reduce the price in kind of day rates of them doing that. And maybe there's a time criticality piece. Maybe, you know, you've got some key products that need to get live as soon as possible, and they're all blocked because they're struggling with certain aspects of infrastructure that you can help with. But to reiterate, the most important thing is that you and your team think and define what cost of delay means to you. And then basically just rate them. So all the things that you choose, maybe choose anything from one thing to as many things as you like that are relevant for yourself. I've gone with 3 here for this example, and effectively just rank them based on this. I find it really useful to actually decide what the numbers mean, so you're not just arbitrarily throwing numbers out. I've seen teams spend a whole day doing these sessions and they just throw numbers out. It just doesn't make sense. It doesn't mean anything. So actually think through like what your numbers actually mean and quantify that. So it might be that you rate higher on time criticality when you have a project that needs to be delivered in the next 6 months, and maybe that's a 2. And maybe you have a product that needs to be delivered, you know, in the next 3 months, and you might put that as an 8. You know, actually quantify what time criticality or reduced cost or whatever it is means to you, so that people aren't just arbitrarily ranking these things. And then job size. I know it's really painful to size things, and you know, during this discovery you won't have even properly scoped things out, but just give it your best shot. The whole point of this is just to get kind of the idea of relative sizes, just so you're not prioritizing things that are fairly equal value, fairly equal cost of delay, but vary vastly in the time it would take you to build it. And then do some simple maths, the equation that I showed in the previous slides, to calculate your weighted shortest job first. And then you'll find something that maybe clearly stands out as a thing you should think about working first. Maybe you've got a couple of things that are fairly close and fairly similar in prioritization, and then it's that conversation piece of actually speaking to your stakeholders and the other people in your organization to figure out which one you want to do. Now, why have I just spent ages talking about a prioritization technique? The reason is I've seen so many times people like kind of half-assing prioritization in technical products. People seem to think that because this isn't a front customer-facing product, they can just pick something, you know, go with something that's got the most pain points is quite an easy one to go to. But actually, depending on what you're aiming for, it's not as simple as that. You know, it's not as simple as doing a 2x2 where you've got value and time and people are just like moving it around and, you know, spending half an hour doing that, which I've seen happen as well. Or people just going for whatever the team is shouting loudest and prioritizing that thing. I really, really do think it's important, if you've set up this team of people to be building shared infrastructure products, and this is going to be a centralized service in your organization, there's a reason you're doing that, and you really want to get it right. So spend time on this. Even if you don't use the weighted shortest job first, just make sure you're breaking that down and really thinking about, what do I want to prioritize? What do I want the outcome for my organization to be? And prioritize based on that. And that's a summary of our first point. Do a discovery, talk to your users, prioritize the right thing, and then you should hopefully build something awesome.
Thanks for that, Poppy. So look, you've done your research and you've figured out what it is that you're going to build and for whom you're going to build it for. That's awesome. You know, how are you going to tell people about this though? Remember that the understanding of this isn't just local for your team, but it's going to impact the rest of the people who are going to be using your platform in the future. Like, what about that shadowy architectural board who's responsible for giving your design the go-ahead ultimately? What about future maintainers of your platform in case that piece of software you've written moves on to be owned by someone else? They might well ask, where's this platform going? I don't understand what it is that you're building. So what happened? Like, the roadmap hadn't been communicated. It's a simple point, but it's often one that teams might miss. either by over or under communicating what the technical roadmap might be for a platform, or by producing artifacts which are inaccurate or ineffective. On the flip side of this, you've got people on the ground asking, who the hell built this? Like, how does it even work? So maybe you've got new folks arriving into your team. Maybe it's being handed over to a different team, and this applies even to SRE folks who might be running your stuff. You know, folks leave, ownership might change, and when things go wrong, usually at 3 or 4 o'clock in the morning, maybe there's no one around to talk to about it. Finding out how something works, especially when it's broken, shouldn't be opaque. So architect theology is a thing. As folks leave or change around, the truth of your beautiful, shining, pristine code base might get lost. Sometimes when you approach a code base, you're as much an archaeologist as you are an architect, and you have to get out your great big magnifying glass and look through CloudWatch logs to understand what might have gone wrong, or end up decompiling binaries on the fly like some crazy hero. Like if teams are spending a bunch of time trying to figure out how to integrate with your thing or how it works, then the time that you wanted to save them originally is lost. You have spent that time. And this absolutely applies to infrastructure and platform development as much, if not more, than product development. So our second principle for today is to build and commit to building a technical vision. It doesn't have to be all singing or highfalutin, as it's going to change. Try and find something reasonably low tech and commit to paper or Canvas or Confluence or MS Paint or something. That process is really effective just for figuring out any side effects that might be incurred from building your design or any surprises in the architecture for future engineers. And so the C4 diagram is one of the great and actionable ways that you can easily start to communicate your technical vision. It's initially created by Simon Brown a little more than a decade ago, but it's still considered to be one of the most descriptive and kind of lightweight mechanisms for communicating system level ideas. And so you start by building a context diagram, the first C, and this describes the overall context of where the system is built and its behaviors at an integration or an ecosystem level. You then continue to produce these Russian doll type diagrams, zooming in at increasing levels of detail, in this case to the underlying container, and how all of the system's components interact. On the left-hand side here, you can see that we've kind of exploded the logging platform into the components that relate to it. And this gives you a better indication of what the moving parts are, how they operate, and those kinds of things. The third C is the component diagram. So here you're diagramming out the individual components themselves, their specifics, and any configuration details or weirdnesses. And then you've got the fourth C, which is the code diagram. So this is where you're actually talking about code stuff, UML diagrams, actors, extended malarkey. Like this might not be as appropriate for your infrastructure platform as it is for a conventional product you might be building, but being able to zoom in at this level, again, might surface any details that might be lost otherwise. So that's one technique. The second technique, which is sort of more forward-looking, is architectural decision records. So talking to the second point around technical visioning and making sure that future engineering teams understand decisions that have been made. Like why leave legacy code when you can leave a legacy of code, right? Architectural decision records are a really lightweight mechanism to document what and how decisions were made when building the software. So these are text files that will live in your code repository, and they basically have this structure whereby you record the name of the decision that's being made. In this case, we're saying we're going to commit to recording architectural decisions in our repositories. You have a date, a lovely date, which just timestamps when that decision was made. The status of the decision, whether or not it's accepted or it's pending or refused. I don't know why you'd record a refused one, but yeah, there you go. The context of the decision that is being made, like the reason why an architectural decision is having to be made in this context, the actual decision that has been made. Again, in this case, we've adopted ADRs to help us do this thing. Any consequences of having made that decision that might relate to the platform or users of the platform or stakeholders of the platform. And then finally, and this is an interesting one, is who was there when the decision was made? Like this is the kind of thing that you can pull from Git maybe, an auto document, but having a vision of who's in the room when a specific decision was made is another useful data point. So an example, say you've joined a new team as an engineer and you're building out some new capabilities around auth in this platform, and notice some strange integration points to an Oracle database, for instance, during a refactoring exercise, but there's no supporting documentation. There's no tests. All the devs that preceded you have all left. It doesn't look like anything's using this database, but there's nobody around that you can actually speak to find that out. Like, wouldn't have been useful if there was an ADR in place describing the decision to include this Oracle database. You are now in a precarious position, though. Is it safe to remove this dependency? How the hell do you know? And so our second principle is build a technical vision. A lack of technical vision hurts both the present and the future.
Awesome. So, we've done a discovery now. We know all about technical vision and what we're going to have to do there. Can we please build now? Are we ready? Sure, why not? Go ahead, build something absolutely amazing. But you might find some people say, sorry, that won't work for our product. And you're frustrated, you did all the user research. Everyone mapped out in their event storming sessions that this was one of their biggest pain points. This is one of the things that they're struggling to achieve. Why all of a sudden are they coming out with that won't work for our product? It's because you probably had some assumptions. Your developers, about a lot about these things. So you've probably made some assumptions about what's going to work well for the different people. You didn't get feedback along the way. And how do we get feedback? Well, I'm going to go back to basics here and just talk about what Agile is. So if you remember all the things you learn in Agile, actually they're about contributing to short feedback loops. So this is a bunch of Agile stuff, from doing Scrum and Kanban to making sure we release code very often, doing spikes, or even prototype testing. All of this stuff is actually in place so that we can get feedback from actual users sooner. So prototype testing, we've not even written any code and yet we're already getting feedback. We want to do spikes before we, make proper robust code. We want to test things out and get answers quicker. We want to release code often into production so that users are actually using the thing as soon as we've actually built it and it's actually ready to be used, so that we can get that feedback quicker. And for some reason, again, we forget a lot of this when we're building infrastructure products. We forget these first principles. And if I'm gonna pick one that I think is really critical when it comes to infrastructure products, it's defining a minimum viable product. And this is super tricky when you're building infrastructure products, I do know, but you've got to remember that the sooner people consume your product, the better. So just because your infrastructure product might take 3 or 4 or 5 months to build rather than 3, 4, or 5 years like a traditional customer facing product might, are you comfortable with the potential that you might spend this time building something that doesn't work for your users and then having to go back and unpick the code to make it usable in the way that they want? It's going to be super tricky. You're going to waste your time. You're going to be frustrated. The people who got excited during your discovery that you're going to actually do some stuff to help them are going to be really disappointed. So you need to define this MVP. And one of the best ways to do this, in my opinion, is story mapping. And I'm sure you've all done story mapping before. It's a really common method for mapping out minimum viable products. So I'll just explain what it is. So basically you just map all the epics that might be contributed to build your product, to build your own product. And the stories under that. But what I really want to highlight is bringing along people who don't know that much about infrastructure and the product you're building. So bring along me as a business analyst who, I don't know how to build a monitoring service. Bring me along. Bring your stakeholders along. Bring along your more junior developers who are new to this kind of work. And these people, empower them to be questioning you with every story, with every epic. What is the actual value out of this? What will we learn by putting this in production now? Can we put this in production later after we've got our first customers using it and still learn something? Answering these questions should help you be able to slice that minimum viable product, but I do know it really is tricky. So it's something you're probably going to have to work at, over a bunch of different workshops and a bunch of different sessions with your team, just really thinking this through. And the other thing that we've heard is a build it and they will come. So this is very, very common in infrastructure products. A lot of people say this. We've even gone so far as stakeholders saying that they'll force people to use a product, which isn't quite great. And the way to mitigate this is to find your customer. So In that discovery phase, you've likely talked to a bunch of people, and the reason that you've prioritized to build this product is because people have told you they want it. So actually decide, one or two different teams who can be your first customer and work with them along the journey when you're building your MVP. Don't wait till you've finished it. We've seen a bunch of times people finish their MVP, you're super excited to get this into customer hands, and yet, it turns out the team that you thought would use it, they're all a bit busy. They've got deadlines, they've got other things going on. They're actually focusing on, different parts of the code base so that they're not quite ready for you yet. Having that conversation with your customer early, you should be able to align your timings and also align the expectation of what they're going to get and work with them, even as you're writing the code and figuring out what it's going to be, actually getting that instant feedback. We're planning on having this configured this way. Would that make sense? What's missing? Those kind of questions, and you'll just get that momentum going with your minimum viable product. And that's the summary. Get feedback, do all the usual agile stuff, but the main thing I recommend is defining that minimum viable product, getting the feedback ASAP.
Well, that sounds pretty simple, Poppy. Like, can we not just stand this up and just throw it into prod? So like maybe you've done your discovery work, you've understood your users' needs and you're ready to build this thing. Why not just start building it and throw it into prod? We've got some templates from the internet that look like they do something similar to the thing that we want to build. And we've got some repos hanging around with some scripts that we could borrow to kind of get us going really quick. That sounds all right. But it's never that simple. Like cookie cutters and pre-built AMIs, Docker images, Helm charts, all of these things, they can take you so far and they'll let you build a really sweet proof of concept of the thing that you want to build. And they'll let you run spikes that you could potentially go live with them. But for me, it's almost a false sense of security. As there's always customizations and things that need to be added and variables that need to be configured to reflect whatever intimate aspects of the surrounding ecosystem that you're developing into. Like, what about security and monitoring? What about resilience and alerting and documentation? What about PagerDuty and callouts? What about onboarding? Like, how do your users know that your stuff exists? And how do you get them started with it? Where do your users go to for help? And what about all of the little bespoke extensions that all of the business units and development teams might need? Unless you're thinking about all of these things proactively, then you don't really have a differentiator. All you really have is a bunch of disparate components. So I guess principle number 4 for us today is to do service design. It's great to be able to come up with a technical blueprint and a vision for the thing that you want to build, as we've discussed. But arguably more important than that is coming up with a plan to get your platform into the hands of your users. So if you can make scripts and templates and docs and guides sort of bulletproof, or as bulletproof as you can, you're going to save yourself an awful lot of unnecessary face-to-face time, which is, it's wasted effort sometimes. And start by drawing out your user's user journey for onboarding onto your platform. This is a useful technique. It's a dead useful skill for getting to grips with what their life might look like. And you can even drill down further into this using value stream mapping if you want to actually find out where waiting times are. So in this example, all we're sort of highlighting is the developer's experience onboarding onto a system. And you can see there's a lot of back and forth of these arrows here, indicating sort of handoff times between the platform team and the engineering team themselves trying to use your product. Like this is a pretty crap user journey, let's face it, for a user wanting to onboard onto your platform. Like the ideal user journey would probably look a little bit like this, where they don't actually need to reach out to the platform team at all because everything's so simple and they've got everything that they need to continue, This is probably the average user journey that you would see, though, for a traditional MVP. There's a couple of interaction points there. There might be an hour or two spent with the platform team working to understand what they need to onboard. But yeah, that's a useful technique. And so the one and done principle is the next sort of thing I wanted to discuss very quickly, which is taken from the context of call centers and customer service. So the one and done principle aims to get a specific action or desirable end state achieved in a single step. So take, for instance, an e-commerce company, and you have someone wanting to call up to change their delivery date for the thing that they've ordered. Now, if the agent answering that call has to jump through maybe 5 or 6 different systems and make 5 or 6 discrete actions to get that one thing achieved, they're a million miles away from one and done, aren't they? And there's a lot of different moving parts there which could go wrong, and customers will be affected and confused by that. So try and keep things self-service. Consider the lifetime of your product and the communication paths between your team and your end users. Every time a user has to interact with your team to get something done or to get help is potential waste that could be spent doing other things. This is all measurable stuff, by the way. And eat your own dog food. It's a cliched adage, obviously, but what we're saying here is that, say you've built your own monitoring platform for the wider organization, and you've built a separate tool, for instance, for artifact hosting or something like that. Actually onboard to the monitoring system your other platforms and services and experience firsthand what that onboarding journey actually looks like. So this is principle number 4, do service design. Customer interaction is great, but your users shouldn't have to depend on you to get shit done. Yes, so this is a complexity thing, isn't it? So I need to invoke a Lambda to spin up an EC2 instance so that I can run a Jenkins pipeline to make a DNS change. Is that really what we're saying here? I guess what we're talking about here is that software is complicated. And there are many good reasons for software getting complicated. But ultimately, we should be building software to help solve problems and delight our users. And the software we build is usually constrained by the organization that builds it. In case you're not familiar with it, this is Conway's law, which states that organizations tend to design systems which mirror their own internal communication structure, which isn't necessarily a bad thing. But when you're talking about building platforms which represent communication paths between teams, it can quickly get very, very complicated very, very quickly. And it becomes more of a problem than for a conventional product sometimes. And remember too that all software is broken. Not to put too much of a downer on things, but I think as was mentioned earlier today around tech debt, every line of code that you write has a high chance of becoming quickly obsolete. Every if statement, every line of configuration has the potential to break or to introduce a weird side effect or to introduce an invisible failure mode. The more complex your solution is, the harder it is to reason about, and the easier it is to introduce defects and problems and downtimes and page duty calls at 2 in the morning. So try and keep things simple is principle number 5. Every component you write as a team is another thing that will need to be measured, maintained, supported, monitored. Granted, you might be limited by existing architectural debt, again, organizational debt or compliance constraints or security safeguards, and that's all kind of fine. I guess the main point here is that just try and think twice before you introduce yet another component to your solution. Every moving part is a potential failure mode. So keep things simple. That's principle number 5.
Awesome. So let's say you've built your product. You've followed all the things that we've said. You've talked to users. You've got actual customers using it. Things are going really well. And you've got a stakeholder who's super happy. They're giving you a pat on the back. They're saying well done. They're shouting about you in group emails. They're super pleased. But you've got another stakeholder who's really confused. They're like, we didn't achieve what we wanted to achieve. And what happened here is we didn't get stakeholders aligned. And it's really, really important that we do that, or else they might have different expectations of what you're here to do, what your platform product team, what your infrastructure services are actually delivering value to the organization. So create a strategy. Get people together to create a strategy, and ideally bonus points if you can visualize this together in a lovely way. And the lovely way that I like is a lean value tree. So for those of you who haven't come across it before, a lean value tree is a way to visualize the strategy in nice little chunks, and it's kind of like a hierarchy thing. So at the top, we've got a vision. So this should be the reason your team is here. So the reason that your team has been put in place, the reason that your organization is spending money to have you develop these shared services. And then under that, you've got goals. So these should hopefully be measurable. You should know, if you've achieved them or not. And then we've got bets underneath that. So this is the things we're going to build to actually meet those goals and then to ultimately meet our vision. I'll give you a couple of examples. So if our vision was maybe to deliver our customer-facing products and services sooner, we might have a goal of reducing the time it takes for product teams to get to production by 50%. We might have a goal about new features needing to be enabled without needing to redeploy. And as you can see, we've got a bunch of different things that you might want to build underneath that could contribute to those goals and ultimately contribute to your vision. Another example is aligning product architecture to reduce security risks. So maybe this is really important to your organization. Maybe you've experienced some security breaches in the past and you just need to get everyone up to scratch fast. It's not always about money and speed. This is actually quite a common one that comes up. And you might have some goals like make sure all customer-facing products adhere to a security code of conduct that your organization's made, reduce the mean time to detect threats by a certain percentage, and you can see a bunch of things that you might want to prioritize under this to achieve that. And the reason I've chose these two examples that we've actually heard and experienced from different organizations is because what you build is ultimately driven by your goals. And what you build is driven by the thing you want to achieve. So actually, if you've not agreed that up front and you've not got all your different stakeholders aligned, even though you might be building a bunch of products and you've got customers, so you've got development teams using it and they're quite happy and they're quite pleased that you're here, it's likely that if you don't achieve that big goal and please your stakeholders, your team's going to get canned and people are just going to be really frustrated because the organization doesn't see what value you've given. They kind of don't mind that you've saved, this development team a little bit of time here and there and a little bit of pain and frustration. They have this big thing in mind that they want you to achieve. So it's really, really, really important to get people aligned on that. So you're actually building the things that are contributing to that. And if you think back to earlier when we talked about the how to figure out what your cost of delay is, this is super linked to that. So ideally, you should have this alignment before you prioritizing the first thing so that you can actually choose those metrics and those things to prioritize on that are contributing to your vision. And that's it. So super simple, easy peasy, get all the stakeholders aligned. No, it's not as easy as it sounds, but it's really something that you and your team should invest the time into because, a lot of people have hearing about these shared services, these shared infrastructure platforms now in the big organizations, and they think it's a really good idea and they've got an idea of what it's going to give their organization. But once it doesn't start giving them what they expected, there is a tendency to let the teams kind of die, and it's really, really sad when there's so much opportunity out there and it's just because they skipped this step.
And this brings us to our next and final section. We've got our stuff to prod, but do you? Well, people are using our stuff, right? What is prod? Like, is prod getting your stuff live, or is it getting into the hands of your users, getting it used, all of your users? How many users? How the fork do you know? This is the last sort of principle we want to talk about today, which is measure the stuff that matters. And it's one aspect, it's one thing that permeates every aspect of what we do. Measure stuff by all means, but measure the stuff that matters to you, your product, and your team. So how do you figure out what matters? Like, luckily you were able to frame your product by KPIs earlier, right? So how did you do? Why not build a really lightweight, and I can't stress this enough, lightweight dashboard or view onto those metrics to see if you're successful? Do you want to increase your users' deployment frequency? Slap a Grafana dashboard in front of it and see. And please celebrate your wins. This is, after all, what it is about for your team. Exactly. If you meet your goals, give yourself a pat on the back. But remember that your job is never done. Not really. You're in the platform business now and things do go wrong. Good job is that you can measure those defects and record them too, right? We couldn't talk about metrics without mentioning the 4 key metrics, which is from the 2018 book Accelerate, which is a book all about performance of development teams. And it's a fantastic read. But the key takeaways for me was around the 4 key metrics, which is a simple indicator for indicating how high performing a team might be. So you've got delivery lead time, which is the time between please and thank you. You've got deployment frequency, the number of times a team might be deploying their software. You've got the mean time to recovery or remediate, which is the amount of time it takes to get a service back running in case something's gone pop. And then you've got the change failure rate, which is the percentage of deployments that might go bad. Now, that's all very well and good for API development, but what about your platform? Turns out the 4 key metrics are even more important if you're building out a common platform for the development teams to host their stuff or to use. Your downtime is other teams' development and prod downtime. You are now a critical dependency in your organization. And beware vanity metrics. Everyone says to measure everything, and data is important, but make sure you pick metrics which are important to you. Nobody gives a shit if you've got 15 nines of availability, but absolutely no users. And equally, what's the point in it taking 2 minutes to onboard your system and use your platform if the thing that you've built doesn't actually support the capabilities that your users need. So principle number 7, measure the stuff that matters. So that's about it for today, folks. I know we're a little bit over time, so thank you for bearing with us. I really hope you've enjoyed our talk about our experiences working in and around infrastructure. We think these 7 principles can really help build the right stuff for the right people at the right time. And please remember that this isn't some magical recipe to be followed. Please do pick and choose what works best for you. And in the spirit of the memocracy, we're going to finish our talk with a TLDR to print out and put in your purse or wallet. Here are our 7 principles. Number 1, do a discovery.
Build a technical vision.
Define your MVP.
Do service design.
Keep it simple.
Have a strategy.
And measure the stuff that matters to you.
And you've probably realised, because we went over time, that we have a lot to talk about on this space. So we're actually going to start a series of articles that kind of go over this. We popped the first one on there today, which actually summarises a bit more detail about talking to users and how to talk to users to get the value for infrastructure products. But we're also going to do an article on all the 7 themes that we talked about today, plus about 4 or 5 more themes that we didn't even get to put into this talk because we didn't have enough time. So keep an eye on there, go and have a look if you like, and find out more information and a couple more practical tips and methods other than the ones we've spoken about today.